In this session 8, we are going to see about Cartesian product of sets. It is a very simple topic. Let us see, what do you mean by a Cartesian product? If we have two sets, for example A and another one set if we have B, then Cartesian product is nothing but A cross B. That is, they are ordered pairs. Just see an example, then you can understand it very easily. A cross B is nothing but, here we have elements of A cross B. In this A cross B set elements, we have element in this model, that is A comma B, that is they are ordered pairs. So this A belongs to the first set capital A, and this element B belongs to this set capital B. So A cross B is nothing but a set of ordered pairs. The first element belongs to the first set and the second element belongs to the second set. That's all. So Cartesian product of two sets is nothing but it is ordered pair of the two sets. If it is A cross B, then the first element will be from the set capital A and the second element will be from the set capital B. Now let us see an example. Let us consider a set capital A is equal to 1, 2, 3, and let us consider one more set, that is capital B is equal to 4, 5. If you want to find A cross B, first we have to cross like this, 1 with 4, then 1 with 5. After that 2 with 4, then 2 with 5. Again 3 with 4 and 3 with 5. So if we do it like this, we'll get the result as 1, 4, 1, 5, then 2, 4 and 2, 5. After that 3, 4 and 3, 5. This is what A cross B. It's very, very simple. Now if you try to find how many elements inside this A cross B, there are 6 elements, 1, 2, 3, 4, 5 and 6. So n of A cross B is nothing but 6. If you see here, number of elements in the set A is 3 and number of elements in the set B is 2. So n of A is equal to 3 and n of B is equal to 2. So if we multiply these two, 3 into 2, we'll get the answer as 6. So we have a formula now, that is n of A cross B is nothing but n of A into n of B. Right. So now you know what is A cross B. Now let us try to find B cross A. Right. What do you mean by B cross A? First let us take and write the B set first. That is 4, 5. And let us try to take the next set, that is A, that is 1, 2, 3. If we have the cross product for B and A, our result will be like this. That is 4 with 1, 4 with 2, 4 with 3, like that. After that 5 with 1, 5 with 2 and 5 with 3. See, if you see these A cross B and B cross A, surely A cross B will not be equal to B cross A, because 1, 4 is not equal to 4, 1. Because now, for example, if you consider this as first place and if you consider this as second place, in the first place 1 sits and in the second place 4 sits, but here it is not so. In the first place 4 sits and in the second place 1 sits. So these two are not equal to one another. So A cross B and B cross A will not be equal to one another. If we want to have A cross B is equal to B cross A, then the only way is A should be equal to B, no other go. Right. So now you know what is Cartesian product of two sets. Now let us try to find Cartesian product for three sets. Right. Cartesian product of three sets is nothing but this is also ordered, not pairs but triplets. So in the three sets Cartesian product there will be three elements for a single element of Cartesian product of three sets. So if we have three set capital A comma capital B comma capital C, then our A cross B cross C will be equal to, this is our single element, but it has three parts. So we are calling it by the name triplets. This first element belongs to the first set, second element belongs to the second set, and the third element belongs to the third set. So small a belongs to capital A, small b belongs to the set capital B, and small c belongs to the set capital C. Right, so this is A cross B cross C. Let us see this with an example. Let us consider the set A as 1 comma 2 comma 3, and let us consider one more set, that is B is equal to 4 comma 5. Now we need another one set. Let us consider that set as capital C, that is 6. Now let us try to find A cross B cross C. First let us find A cross B. A cross B is very simple, you know well, that is 1 with 4, 1 with 5, similarly 2 with 4 and 5, and then 3 with 4 and 5. Our result is like this. With this result, with this A cross B, we have to find cross C. So if we try to find A cross B cross C, A cross B cross C, then it will be like this, that A cross B is as it is. With this we are going to cross C element, that is 6. Now if we cross it, 1 comma 4 will act with 6, then 1 comma 5 will act with 6, like that it will be going on. In case if we have one more element, for example if it is 6 comma 7, then 1 comma 4 will be acting with 6 first, then the 1 comma 4 will be acting with 7 next. But here we have only one single element 6, so each element of this set A cross B will be acting only once. So our result will be 1 comma 4 comma 6, then 1 comma 5 comma 6, 2 comma 4 comma 6, 2 comma 5 comma 6, 3 comma 4 comma 6, and 3 comma 5 comma 6. So this is called by the name triplets because each element has three elements. Right. Now let us find its coordinate number, n of A cross B cross C. If we count it, 1, 2, 3, 4, 5, 6 elements are there. So our n of A cross B cross C will be equal to 6. Is it possible to get the 6 by set A and set B and set C? Yes, we can get it very easily. If you see number of elements in set A, that is 3. Number of elements in set B is 2, and number of elements in set C is 3. If you multiply these 3 into 2 into 1, we'll get the same answer as 6. So our n of A cross B cross C is nothing but n of A into n of B into n of C. This is what the basics of uh, Cartesian product. You can extend it for 4 sets and for further. Now let us try to solve two very small and simple sums. Right. Let us consider a set capital A, and it is given this A cross A contains 16 elements, and from this A cross A they are showing us two elements. First element is 1 comma 3, and then the second element is 0 comma 2. The question is find the elements of A. See here, we have to find what is A set, but the elements we received from the set A cross A is 1 comma 3 and 0 comma 2. So this 1 belongs to the first set and this 3 belongs to the next set, but both are A set. So surely the A set has this element 1 as well as this 3, this element 0 as well as this element 2. So A cross A has 16 elements. Set A has now 1, 2, 3, 4 elements. So if we multiply 4 into 4, we'll get the answer as 16. So our set A must be this 0, comma 1, comma 2, comma 3. It's very simple. Now let us see one more problem. Here it is given if A cross A has 16 elements and S is equal to A comma B belongs to A cross A and A is less than B. This element A is less than B. Moreover, they are saying minus 1 comma 2 and 0 comma 1 are two elements of S. These two are the two elements of the set S. Then find the remaining elements of S. How to find it? Right. It is given A cross A has 16 elements. So we can write n of A cross A is equal to 16. You know very well n of A cross B can be written as n of A into n of B. So n of A cross A can be written as n of A into n of A. That is equal to 16. The side n of A the whole square. So we can write this as 4 square. So if you equate these two, we'll get the answer n of A is equal to 4. So we have a conclusion now. Set A has 4 elements. Right. S is nothing but a subset, or the elements of S is taken only from A cross A. So the set A has only 4 elements. A cross A has 16 elements. Out of the 16 elements only they received S. Right. Now what will be the 4 elements? The clue says minus 1 comma 2 and 0 comma 1 are two elements of S. So this S has two elements. One element is minus 1 comma 2 and another one element is 0 comma 1. If you see, all the 4 elements are distinct with one another. So it is a very important and main clue for us. According to this statement, this A comma B belongs to A cross A. It implies the first element belongs to the set capital A and the second element also belongs to the set capital A. So this element minus 1 is from A, this 2 is also from A, 0 is from A and 1 is also from A. So all these 4 elements are from A. Already you know number of elements in the set A is only 4. So if we collect all these 4 elements, we'll get the value of set A. So our set A will be minus 1, then 0, then plus 1 and 2. We have arranged like this. Right. Now let us come to this clue. It is given S is equal to A comma B. S is equal to set of elements. This is in the model of A comma B that belongs to A cross A. Moreover, the next clue says this A is less than B. That is, the first element is lesser than the second element. So let us do one thing. Let us try to find all the S elements such that whenever we have this ordered pair, the first element should be lesser and the second element should be bigger. Both are from A set, A cross A. This is also from capital A. This is also from capital A. So let us do a small technique. If you want to find S value, it is very simple. This S is only from A cross A. So our A cross A will be like this. From here we cannot choose all, because when writing S, the first element should be lesser than the second element. So from here let us choose an element, because these 4 makes the first element and these 4 makes the second element. So from this 4 let us choose an element, that is minus 1. If I choose minus 1, then I have to choose the elements from the back set such that the back set elements should be greater. So I have to choose a number. If I choose minus 1 from the front set, then I have to choose a number from the back set which is greater than minus 1. So except minus 1, 0 is greater than minus 1, 1 is greater than minus 1, and 2 is also greater than minus 1. So for S we can choose minus 1 comma 0, minus 1 comma 1, minus 1 comma 2. Moreover, if I choose 0 from the first set, then I have to choose bigger numbers than 0 from the back set. So we cannot choose minus 1 because it is lesser. We cannot choose 0 because equal to 0. So if I choose 1 and 2, these two are greater than 0. So using 0 we can frame like this: 0 comma 1 and 0 comma 2. Similarly, if I choose 1, we cannot choose these three elements because these three elements are lesser than 1. We have to choose only the element which is greater from the back set. So if I choose 1, I can select only 2. If I take 2 from this front set, I cannot take anything from the back set. In this way, if we fix it, our S will be like this, right? That is minus 1 with bigger number 0, minus 1 with 1, minus 1 with 2. Then if I choose 0, if I choose 0, the greater number is 1, the greater number is 2. If I choose 1, the greater number is only 2. If I choose 2, nothing is greater than 2 here. So these are all the elements of S. But they are giving us these two elements. So the question is, what are the remaining elements of S? They have given us these two elements of S. So let us mark these two elements, that is minus 1 comma 2 and 0 comma 1. That is these two elements. If we leave these two elements, our remaining S will be minus 1 comma 0, minus 1 comma 1, 0 comma 2, and 1 comma 2. It is very simple topic. I hope you would have understood all these things. Revise once more and try to do more problems from your textbook. Thank you.